We have a lot of reading in this question. We want two of the suggested answers are correct. To get full credit, you must choose both correct choices. Only no partial credit will be given for one choice. So 2 are the best in each case. So we have a collision going on, which we usually think of as the conservation of momentum, and whether or not it's elastic is the kinetic energy equals the kinetic energy afterward. So we are given that they are the same mass, they're free to move. The cart's wheels have negligible mass. Now this seems like an odd thing to say. So the cars, if they don't have much mass, and their wheels, they're round, we might be thinking about the moment of inertia. And so if the mass is 0, the moment of inertia will be 0. And that's important because remember when we talk about kinetic energy being conserved or not being conserved, well, gravitational potential energy can be converted to kinetic, but there's 2 kinds of kinetic, linear and rotational. And momentum might be conserved, and that would be the total of the linear and the rotational. So what this is doing is making it clear that there is no rotational momentum involved in this problem. So then we have more initial conditions, which is initially at rest. So you might want to add that to the diagram. V0 is 0. Cart 2 has a compressed spring-loaded plunger. So immediately we should be thinking, okay, it's compressed and it's spring-loaded, so there's potential energy of the spring. That spring, this spring right here, has energy stored in it. And so then when the cart collides with it, it's going to explode. And when it explodes, it is going to release that stored energy. So if we were looking at this from just a conservation of momentum perspective, then we would have a collision, and the momentum would be conserved of the system. But when we have this plunger being activated, that means that there is work being done on the system, so that the momentum before and after will not be equal because there is an external force. Ironically, it's sort of internal, but it's external to the system that's doing work on the system. So we would not expect the momentum to be conserved in this case because there's an outside force doing work on it. All right, so continuing on, and that is essential to understanding this question. Non-negligible amount of energy. So, of course, it's doing work on the system then. I'll even write that down. Work on the system. So, P0 does not equal P. During the collision, plunger pops out, staying in contact with the cart for 0.1010 second as the spring decompresses. Negligible mechanical energy dissipates. So why are they telling us that? Negligible energy dissipates means that there is no energy going into Q or vibrational or sound and so forth. So normally if we had a loss of energy, we know it's being converted to another form, degraded energy that's not available to do useful work. So taking the right as positive and the velocities of the collisions, what are the possible velocities? What are the possible velocities? So we know that P0 equals P, the conservation momentum, is not on the table because work has been done on the system. But then, if work is done on the system, then the total energy should increase. Because in this process, we have had elastic potential energy converted to kinetic energy. So now there's more kinetic energy. We're already being told there's no energy dispelled anywhere else. So if we look at the initial kinetic energy, we have 1/2 mv squared, and we will just call it 1/2 mv squared. Now we know they have the same mass, and the velocity is 1, so the potential kinetic energy is 1/2 m. That's the kinetic energy. So if we look at the situation A, and we're looking for 2 of these that could be possible, well, situation A would have exactly the same kinetic energy. So it can't possibly be choice A. If we look at choice B, we have 1/2 m, and the velocity is 1/2. So we have 1/8 m, which is definitely less than 1/2 m. And there's two of those, one for cart 1 and one for cart 2, so that's 1/8 times 2m, or 1/4 m, which is still less. So it can't be choice 2 because it's less kinetic energy. Cart 1 and cart 2, well, we know this is 1/8 m, the first one. And the second one, 1/2 m times 3/2 squared. So 1/2 m, 9/4. Well, 9/4 is over 2. And so we had 9/8 m, which is greater than the initial 1m. Plus, there's this other 8, so we end up with 10/8 m, giving us 1.25. So this is a possibility because it is greater than. And we would think choice 2 would be, and we can now just look at the answers and determine that if the speed of one of them is less by 0.5 and the other one's greater by 0.5, that squaring of the velocity has a disproportionate effect on the larger velocity. So these two don't balance out when they're squared. The increase here is greater than the decrease in kinetic energy there, so that makes this larger than if we had done the average. And so this is going to have the same kinetic energy right off the bat as the initial case, plus a heck of a lot more. And so this one is also more than. And that's why our choices are C and D.